being blamed for playing a role in the creation of GWPF. It's one of the better things I get blamed for, but anyway. What I'd like to talk about today is something rather dear to my heart but obscure to everyone else, which is the narrative of global warming. It is a narrative that we've approached defensively, but which I think is intrinsically implausible, if not absurd. At any rate, the question is, how does this come to be? And it seems to me part of the reason is how little science permeates normal discourse. Over a half century ago, C.P. Snow, some of you might remember the name, he's a novelist, English chemist and physicist, served in the civil service and even briefly in the government, World War II. He examined the implications of what he referred to as two cultures. And I'll quote from him briefly. "Good many times I've been present at gatherings of people who by the standards of the traditional culture are thought highly educated and who have, with considerable gusto, been expressing their incredulity at the illiteracy of scientists. Once or twice I've been provoked and have asked the company how many of them could describe the second law of thermodynamics. The response was cold. It was also negative. Yet I was asking something which is the scientific equivalent of, have you read Shakespeare? I now believe that if I had asked an even simpler question, such as, what do you mean by mass or acceleration, which is the scientific equivalent of saying, can you read? Not more than 1 in 10 of the highly educated would have felt that I was speaking the same language. So the great edifice of modern physics goes up, and the majority of the cleverest people in the Western world have about as much insight into it as their Neolithic ancestors would have had. Trouble is, I don't think a lot has changed in the 60 years since C.P. Snow made this assessment. And although maybe it's extreme, some would, I suppose, say that ignorance of physics might not impact political ability, but it almost certainly impacts the ability of non-scientific politicians to deal with nominally science-based issues. Moreover, the gap in understanding is also an invitation to malicious exploitation. Certainly seeing that. Given the democratic necessity for non-scientists to take positions on scientific problems, belief and faith inevitably replace understanding, though trivially oversimplified false narratives serve to reassure the non-scientist that they are not totally without scientific understanding. The issue of global warming, unfortunately, offers numerous examples of this. I'd like to begin this lecture with an attempt to force scientists, at least those in the audience, to come to grips with the actual nature of the climate system and to help motivate those of you who are not scientists in this audience, but who may be in Snow's 1 in 10, to move beyond the trivial oversimplifications. At any rate, so we'll start with the climate system. And what I'm going to say now, and keep this in mind, I'm not going to argue here about whether the temperature went up 1/100 of a degree or down 1/100 of a degree. That's nonsense. Nothing is measured that well. I'm not going to talk about any of the minutiae that obsesses the system. Everything I'm going to say here is not in the least controversial. And I say that honestly. I expect that anyone with a scientific background will follow the description, and I'll try and make it clear to those who are not as best I can. So, first thing I'll say is we're dealing with a system that consists in two turbulent fluids, the atmosphere and oceans, interacting with each other. By turbulent, I simply mean that it is characterized by irregular circulations like you find in a gurgling brook or a boiling pot. That's nothing special, but the dimensions of the brook and the pot are small, and the eddies, the turbulent elements, are now on the scale of the planet. They are weather systems, they are larger systems even. You can speak of a fluid that is not turbulent as being laminar, but any fluid that is forced to move fast enough becomes turbulent. By interaction, all I mean is that the ocean and atmosphere exchange heat with each other and exert a stress on each other. Nothing that hard there. Now, the second thing is, these fluids are on a rotating planet that is unevenly heated by the sun. Again, I don't think there's any controversy there. The important point here, though, is that the motions of the atmosphere, and to a lesser extent the oceans, are generated by the uneven heating. And the uneven heating, the sun can be perfectly steady, but of course its rays are incident directly at the equator and are just skimming the pole. And it's that difference that generates the circulation system. To give you an example, without that circulation system, the poles would be vastly colder than they are today. Okay, so that's one thing. Now, as far as the rotation goes, that has a lot of implications, but for our purposes, the most important is the heating is averaged around a latitude circle. Dynamic implications we can skip for this. Okay, the oceans have circulations and currents operating on timescales ranging from years to millennia, and these systems carry heat to and from the surface. Now here you have to understand, you're familiar with the atmosphere, most of you. I mean, we live in it. The ocean, of course, is much denser, and its flow speeds are much slower typically than those in the atmosphere. The circulation systems have much longer time scales, and there are circulation systems that are essentially coupling the deep ocean with the surface that can take, as long as a millennium or more. The important part about these circulation systems is they exchange heat with the surface. They carry heat from the surface into the ocean and back from the ocean back to the surface. What that means is the surface of the Earth is never in balance with the sun. There's always storage and release of heat from the oceans. So that's worth keeping in mind. We'll come back to it because the time scales become very important. Now, in addition to the oceans, the atmosphere is interacting with a hugely irregular land surface. That's a subtlety, but it's a good test in a way. You have the Himalayas primarily, but also the Rockies, the Andes, and others. The air has to flow around them. What you may not realize is not only does that distort the flow, but it excites waves in the atmosphere so that the distortions are conveyed around the Earth and play a vital role in regional climate. And that becomes a test of the models. Are they good at regional climate? And the answer is they're very poor at that. So there's a basic process that is there for testing. Now, a vital constituent of the atmospheric component is water in the liquid, solid, and vapor phases, and the changes in phase have vast impacts on energy flows. Each component also has important radiative impacts. Leaving the jargon apart, everyone here knows it takes heat to melt ice, and it takes a further amount of heat for the resulting water to become vapor or steam. That's something that I think everyone is comfortable with. Now, it is also the case, well, humidity simply refers to the amount of vapor in the atmosphere, and the heat flow is reversed when you have condensation of vapor into water and freezing of water into ice. Now, for instance, it is the release of heat when water vapor condenses that drives cumulonimbus towers, these huge clouds. And to give you just some sense of the energy involved, a single cumulus tower is releasing energy on the level of a characteristic H-bomb. I mean, these are important exchanges. Hurricanes are energetically huge compared to our weaponry. In any event, clouds consist of water in the form of fine droplets and ice in the form of fine crystals. Normally, the cloud is an area where air is rising and the condensed material is just being held up by the rising air until the ice particles and the droplets get large enough and heavy enough that they fall through the rising air. Then we have rain and snow. Now, essentially, this is important for its own energetics, but it's also important because the clouds, consisting in whether it's water-based or ice-based, are terrifically important radiatively. What that means is, of course, as you all know, they reflect sunlight, but they also absorb and emit in what is called the infrared, the heat part of the spectrum. And we'll come back to that in the greenhouse discussion, but for the moment, you should realize that although it's important that CO2 is a greenhouse gas, far and away the most important greenhouse gases, or substances, I should say, are water vapor and thin clouds, cirrus clouds. Compared to these, CO2 is very minor. Okay. Now this one is sticky. I mean, this is the energy budget. This is where the greenhouse effect comes in and so on. The energy budget of this system involves the absorption and re-emission of about 200 watts per square meter. Doubling CO2 involves a 2% perturbation to this budget. So do minor changes in clouds and other features, and such changes are common. Now, first I realized in speaking to friends who are not scientists, I better explain that watts per square meter is simply the unit by which we measure energy flow. Don't worry about its length or anything. Turns out the Earth receives about 340 watts per meter squared from the sun. About 140 watts are reflected back by the surface of the Earth, but mostly by clouds. So you have 200 watts, as stated here, net coming in. And if you were to establish balance with space, the Earth would have to emit 200 watts per meter squared. Now, the sun radiates in the visible, and it turns out that temperature determines where the peak in the spectrum is. Sun is 6,000 degrees. There, the peak is the visible. For the Earth to balance it, it would have to have a temperature of about 255 degrees Kelvin. Kelvin, I should mention, if you don't know, is simply centigrade beginning at minus 273. And that is something Lord Kelvin discovered long ago, that minus 273 degrees centigrade is the coldest you can be. It's where kinetic motions stop. And so if you start there, you have an absolute measure of temperature as opposed to centigrade, which is tied to water. Okay, so essentially the Earth is emitting at 255 Kelvin. And there, the spectrum is in what's called the infrared, thermal radiation. Okay, that's fine if you have no atmosphere. Now, one has performed a trick already. One has no atmosphere, but has clouds to reflect sunlight. But let's skip that for a moment. Now, unfortunately, or fortunately for us, the Earth does have an atmosphere and oceans, and this does introduce a lot of complexity into the system. And so I'll warn you beforehand, what I'm going to say now it doesn't require much understanding, but it requires concentration. If you want, you can read it later if I'm not clear enough. But let's start how the issue works. The ocean begins evaporating. So the atmosphere now has water vapor. The water vapor absorbs very strongly in the infrared. So now the surface of the Earth can no longer radiate to space. It's get blocked by the water vapor. What happens when you're heating it? Well, the surface is heating up, and then there's conduction, so it heats the air next to it. So you now have hot air and it's colder above. What happens when that? You start convecting. It starts boiling like a boiling pot. Now, there is a difference, however, because you're dealing with the scale of the atmosphere. It's, kilometers. So as the air rises, it expands because the density is decreasing with height. You know that when the airplanes are flying, it's not very dense. When the air expands, it cools. And this has a very important impact on the greenhouse. Because it says when you turbulently mix the atmosphere with convection, you don't get a temperature that's homogeneous, you get a temperature that's decreasing with height. Now, the process is more complicated than that, but it ends up giving you something like 7.5 degrees centigrade, 6.5 per kilometer. So the atmosphere is now getting colder with height, and we know that. Now, what happens then is twofold. You have the water vapor, which is also, less and less above you, but in addition, the water vapor that the atmosphere can hold actually goes down markedly as the temperature goes down. At any rate, as a result of all of this, there is some height where there's so little water vapor above you that now the radiation from that height can reach space. Okay? That height now must have a temperature of 255. Okay? That's fine. But now we've said convection means the temperature is increasing as you go down. So if the level where the radiation can leave to space is 255, the ground has to be warmer. Has to be about 33 degrees Kelvin or centigrade warmer, 288. That difference is referred to as the greenhouse effect. Now, that is actually not as complicated as it should be, because, okay, we talk about water vapor, but if you have any of these thin clouds and they're above the level of radiation of emission, which is about 5 kilometers in the atmosphere, the clouds can be well above that. And they absorb so strongly that the radiation coming from the water vapor can't make it to space. It gets blocked by the clouds, and the emission level is the top of the cloud. So you have a fairly messy situation, and now if you add CO2 to it, what happens? Well, you're increasing the amount of greenhouse gas, so you're raising the level which is emitting, because now you can't get it out of there, you're blocking it a little more, so you raise it, but it's convecting, so that new level is colder. And because it's colder, it's not balancing the incoming radiation. It's no longer 255, it's a little bit colder. And so for the system to return to any sort of balance, the whole system has to warm. That's greenhouse warming from CO2. And when you do the calculation, it would be equivalent to changing the energy balance. We said this involves 200 watts per meter squared by about 3.5 watts per meter squared. That's about 2%. It turns out if you change the area of the clouds a little bit, if you change the height of the clouds a few 100 meters, if you do any number of things, that also will produce 3 watts per meter squared, 3.5, 5 watts per meter squared. The system has innumerable degrees of freedom. Okay, that's the tough part. Now, the next part is also important. It is important to note that such a system will fluctuate with timescales ranging from seconds to millennia, even in the absence of explicit forcing other than a steady sun. Now, you'll occasionally see in the literature, and not so occasionally, people say, is it the sun? Is it greenhouse? As though you have to do something to cause climate to change. But all you need is a steady sun. And all of you know that. None of you have the least problem envisaging the steady stroking of a violin string causing it to vibrate. You don't cause it to vibrate by going like this. And the system we're talking about is similar in that respect, except the modes of oscillation in the atmosphere and the ocean are more complex than the vibrations of a violin string. But, you know, essentially it's saying that for the atmosphere and the ocean, given the massive scale of the ocean especially, the time scales for oscillations within this system that have no explicit forcing can be as long as 1,000 years or more, and certainly much longer in most cases than our instrumental record. We have some short examples like El Nino, and so, which are typically 4 years, 5 years. But we have much longer scales that are occurring because of these things. In the atmosphere, one of the earliest things I worked on was something called the 26-month oscillation. You go up about 16, 20 kilometers over the equator. The air is going from east to west for a year, west to east for a year. It turns out this is something it will do by itself with no forcing, just from the nonlinear interaction of the system. Okay, so, you know, nature has many examples. All of you probably know about the 11-year sunspot cycle. It's not as though anything is forcing 11 years on the sun. It's doing it purely internally. Some of you may know that the Earth's magnetic field is generated by a dynamo-like current in a molten interior, and every few 100,000 years it flips. And there's nothing pushing it to flip. It just does it. Okay, so there you have the climate system, and I would argue totally unarguable. It is true, of course, such systems also respond to external forcing, but such forcing is not needed for them to exhibit climate variability. Okay, so there you have the physics. The next part is the popular narrative and its political origins. And this is the last text slide I'll essentially have. Here is the currently popular narrative concerning this system. The climate, a complex multi-factor system, can be summarized in just one variable, the globally average temperature change, and is primarily controlled by the 1 to 2% perturbation in the energy budget due to a single variable, carbon dioxide, among many variables of comparable importance. Now, I would suggest this is an extraordinary pair of claims right off the bat. It's based on reasoning that borders on magical thinking. And yet it is the narrative that has been widely accepted even among many skeptics. This acceptance is a strong indicator of the problem Snow identified. Now, it goes further. Many politicians and learned societies endorse CO2 as the controlling variable, and although mankind's contributions are small compared to much larger but uncertain natural exchanges of CO2 with both the oceans and biosphere. Biosphere means plant life on Earth. We're confident that we know precisely what policies to implement in order to control CO2. I don't know what one says about this. I mean, it's true over the last 200 years, several scientists have put forward similar views. Do you have any water? But until the 1980s, what you may not realize is whenever these were suggested, they were dismissed with perfectly good arguments. It wasn't as though everyone said, aha, or they forgot. There were reasons they rejected. In 1988, when the NASA scientist James Hansen testified to the US Senate that summer's warmth reflected increasing CO2, even Science magazine, which is highly biased these days, reported that the climate science community was skeptical. The establishment of this extreme position as dogma during the present period, I would suggest, as Nigel said, is due to political actors and others seeking to exploit opportunities that abound in the multi-trillion-dollar energy sector. There are numerous examples of this, but I'll point to two that I sort of like, and they were very important. One example was a man called Maurice Strong. Some of you may know the name. He was a global bureaucrat and wheeler-dealer. He spent his final years in China apparently trying to avoid prosecution for his role in the UN's oil for food scandals. At any rate, Strong is frequently credited with initiating the global warming movement in the early 80s. I'm not sure that's correct, as I'll point out, but he did play the major role in engineering the conference, the Rio Conference in 1991, that produced the United Nations Framework Convention on Climate Change. And this was the agreement that virtually every nation, including my own, signed, essentially endorsing the CO2 climate narrative, and it initiated the series of international meetings, the COP meetings, that continue to the present, and these meetings presumably are designed to plan the control of climate. They could be called the Canute meetings, but there were others who played a major role as well. One of them was the Swedish Prime Minister Olof Palme, and his friend and science advisor, Bert Bolin. Bert Bolin was the first chairman of the UN's Intergovernmental Panel on Climate Change. And they already in the 1970s were pushing an anti-carbon movement. Their motivation was to overcome resistance to nuclear energy by demonizing coal. And to a certain extent, Maggie Thatcher also was attracted to this view. The trouble is the political enthusiasm has only increased since then, and political ideology has come to play a major role. I'll only go through this briefly. I mean, you have things like the Christiana Figueres, who was executive secretary of the UN's Framework Convention on Climate Change that I mentioned earlier. And she looked at this as the means for intentionally changing the world's economic system. Pope Francis' closest advisor, Cardinal Oscar Rodriguez Maradiaga, criticized movements in the US that had preemptively come out in opposition to Francis' planned encyclical on climate change. And his quote was, "The ideology surrounding environmental issues is too tied to a capitalism that doesn't want to stop ruining the environment because they don't want to give up their profits." And this extends to the proceedings of my National Academy of Sciences, which, alas, I'm a member of. And they had a typical paper recently, I think last August, typical of these papers, we'll come back to that with the IPCC. There was an article, and we'll see with these articles, they're just littered with could-bes and would-bes and so on. I think lawyers would call this plausible deniability. But then they concluded that collective human action is required to steer the Earth system away from a potential threshold and keep it habitable. I love this constant mixing of the required and the potential. The authors said that this would involve stewardship of the entire Earth system, biosphere, climate, and societies, and that it might involve decarbonization of the global economy, enhancement of biosphere carbon sinks, behavioral changes, technological innovations, new governance arrangements, and transformed social values. That's quite a package. But remember, in a world that buys into the incoherent precautionary principle, even the mere claim of remote possibility justifies extreme action. I think this is dangerous in many areas, not just in science. But the question is, what are they seeking? And I would argue that what is happening, and I don't know if it's true in England, but I feel this strongly in the States, where the left and the regulatory states backed by the wealthiest people in America. And you have this odd thing where the left in the US is now the wealthy, the middle class and working classes are the right, and then when you get to the classes that are on welfare, they're back on the left. And I have the feeling that the people who are pushing this issue are desperately seeking the power to roll back the status and welfare that ordinary people have acquired and continue to acquire through the fossil fuel-generated industrial revolution, and return them to their presumably more appropriate status as serfs. Many more among the world's poorest will be forbidden the opportunity to improve their condition. And I think that's a serious thing. Nevertheless, when you present these claims that I've just mentioned to the leaders of our societies and governments, along with the bogus, utterly bogus claim that 97% of scientists agree, our leaders are afraid to differ and proceed lemming-like to plan for the suicide of industrial society. And again, nothing better illustrates the problem that Snow identified, because with the least understanding, this should not perpetuate itself. Now, interestingly, ordinary people, as opposed to the educated elites, tend to see through this nonsense. And the question is, what is it about our elites that make them so vulnerable, and what is it about many of our scientists that lead them to promote such foolishness? I would suggest the answers cannot be very flattering. So let's look at this. When you consider the vulnerable elites first thing I would point out, and I think this is true everywhere, they've been educated in a system where success has been predicated on their ability to please their professors. In other words, they have been conditioned to rationalize anything. Orwell, I think, made the point there are some things so stupid only an intellectual could believe them. They've been onto something. The second is, while they are vulnerable to false narratives, they are far less economically vulnerable than ordinary people, and they believe themselves wealthy enough to withstand the economic pain of the proposed policies, and they are clever enough to often benefit from them. Third thing that I think is important is the narrative is trivial enough for the elite to finally think that they understand science. I'll come back to that in a moment. And for many, especially I think on the right part of the political spectrum, the need to be regarded as intelligent causes them to fear that opposing anything claimed to be scientific might make them appear ignorant and this fear overwhelms any ideological commitment to liberty and free markets that they might have. Again, none of this applies to ordinary people, and I would suggest this may well be the strongest argument for popular democracy and against the leadership of those who, quote, know best. Now, what about the scientists? First of all, scientists are specialists. Few, very few, are expert in climate. This includes many so-called climate scientists who became climate scientists in response to the huge increases in funding that accompanied global warming hysteria. One essentially did something that even Stalin couldn't quite succeed in doing with Lysenko. We've actually created a huge new community in a field based solely on a political position. The funding, for those of you who haven't followed it, in the US at least, I don't know, I'm pretty sure it was almost the same in England, in the early 90s, increased by a factor of 15. There are almost no sciences that can absorb that, so you create new ones. This also led to the issue of impacts, and we'll come back to that in a moment. But it means, even if you never studied climate, if you studied cockroaches and you wrote the proposal, Cockroaches and Climate, or how they'll increase, there was funding for you. Okay. Now, the other thing is scientists have political positions. And it's been tempting. Many have been enthusiastic about using their status as scientists to promote their political positions. This is not unlike celebrities whose status I think a lot of scientists aspire to. As examples, again, I don't know if they fit the UK, but in the US, you had huge movements within the scientific community against nuclear weapons, against the Strategic Defense Initiative, against the Vietnam War, and so on and so forth. Okay, I think scientists are also acutely and cynically aware of the ignorance of non-scientists and the fear that this engenders. The fear leaves the vulnerable elites particularly relieved by assurances that the theory underlying the alarm is trivially simple and that all scientists agree. My favorite on this is our former Secretary of State, my former Senator, John F. Kerry, when he stated with reference to greenhouse warming, quote, "I know sometimes I can remember from when I was in high school and college, some aspects of chemistry or physics can be tough, but this is not tough. This is simple. Kids at the earliest age can understand this," end quote. Have you seen the greenhouse effect is not all that simple. I would suggest only remarkably brilliant kids would understand it. And given Kerry's subsequent description of climate and its underlying physics, it was clear he was not among them. At any rate, so we have this. Now we come to the evidence, which you're besieged with on a daily basis. You might be wondering at this stage, and I say the underwhelming evidence, what about all this evidence for climate change? What about disappearing Arctic ice, the rising sea level, the weather extremes, the starving polar bears, the Syrian civil war, and all the rest of it? The vast variety of claims makes it impossible to point to any particular fault that applies to all of them. Of course, citing the existence of changes, even if correct, though surprisingly often not, would not implicate global greenhouse warming per se. And, often the connection is not there. Nor would it point to danger. Moreover, most of the so-called evidence refers to matters for which you have no personal experience. Some of the claims, such as those referring to weather extremes, contradict both physical theory and data. The purpose of the claims is quite obvious. It is to frighten and befuddle the public and to make it seem like there is evidence where there is in fact none. If there is evidence of anything, it is of the correctness of C.P. Snow's observation. Some examples will show what I mean. Let's go through a few. First, logically, for something to be evidence, it must have been unambiguously predicted so that it is a test that could be failed. This isn't a sufficient condition, but it is necessary. Now, I have a figure here which illustrates how silly this can be. What this figure does is show the IPCC model forecast for the summer minimum in Arctic sea ice in the year 2100 relative to the period 1980 to 2000. So they're saying, how much is it going to go down from that period? And each of these curves is a different model. I don't have a pointer here, but that's okay. And what you can see is, don't worry, for 2100, there are models predicting anything from complete elimination to almost none. That's great. That's really great. If, there is a model for any outcome. It's a little like the formula for being an expert marksman. Shoot first and declare whatever you hit to be the target. So, that's one form of argumentation that one has to deal with. Now, when it comes to temperature extremes, is there any data to even support concern? And here you have something interesting, because I'll come to today's release. The data shows no trend in extremes. On top of that, the IPCC agrees the data shows no trend in extremes. Even a man called Gavin Schmidt, who is the successor to James Hansen at NASA's New York shop, remarked that general statements about extremes are almost nowhere to be found in the literature, but seem to abound in the popular media. He went on to say that it takes only a few seconds' thought to realize that the popular perceptions that global warming means all extremes have to increase all the time is nonsense. Why is it nonsense? There are a lot of reasons. At the heart of this nonsense is the failure to distinguish weather from climate. Thus, global warming refers to the welcome warming of about 1 degree centigrade since the Little Ice Age about 200 years ago. On the other hand, weather extremes involve temperature changes on the order of 20 degrees centigrade over short periods of time, 1 day, hours. Such large changes which characterize weather have a profoundly different origin from global warming. The large changes, crudely speaking, result from winds carrying warm and cold air from distant regions that are very warm or very cold. You look at a map and you see temperature changing north to south, and you see the wind systems traveling around in the usual cyclonic and anticyclonic phases. Okay, so essentially, these waves, the strength of the wind in these waves, depends on the temperature difference between the tropics and the pole, okay? And what do the modelers claim? They claim in a warmer world, the poles will warm more than the tropics. What will that do to the difference? It'll reduce the difference. So the waves, instead of getting stronger, will get weaker, and their ability to carry air from cold and warm regions to where you are will diminish. And so if you were to see an increasing number of extreme temperature events, what would that be evidence for? It would be evidence for global cooling. Now, this is this is the physics underlying it. The trouble is, people who are not scientifically literate and who do not like to think about it, seem incapable of distinguishing global warming from temperature extremes due to weather. Fortunately or unfortunately, there doesn't seem to be any discernible trend in weather extremes, but there is certainly greater attention paid by the media to weather, and the exploitation of this, quote, news coverage by people who realize that projections of catastrophe into the distant future are not compelling. You therefore need to convince the public that the danger is immediate, even if it isn't. Now, this has also been the case with sea level rise. Sea level has been increasing about 8 inches, 6 inches a century for hundreds of years. We have clearly been able to deal with it. In order to promote fear, however, those models that predict much larger increases are invoked. As a practical matter, it has long been known that in most coastal station locations, changes in sea level are measured, when measured by tide gauges, are primarily due to changes in land level, both tectonic and land usage. Okay, so sea level is another case where you just misrepresent things. Now, the small changes in global mean temperature, or temperature change, is often used as the evidence. I went back to the standard narrative. But even there's something really peculiar. If you look at the temperature change, even during the period 1978 to 1998, and you assume all of it is due to man, and then say, how sensitive is the climate? You'd end up saying that climate, in all likelihood, is not very sensitive. Moreover, the UN IPCC didn't say all of it. It said most of it, could be 51%, which point you're really down to something you wouldn't worry about. Does this matter? No, of course not. When politicians read that as the iconic statement of the IPCC in my country, Senators McCain and Lieberman said, now we have the smoking gun. We must do something. That scientists can say something that means it's not a big problem and assume that the politicians will say it means that it is proof of coming disaster, we have a problem. Then there is the issue of cherry picking, and I'm almost through. For instance, there's recently been a claim that Greenland ice discharge is increasing, and this is probably going to be increased by global warming. So be it. On the other hand, they omit to mention the report by both NOAA, our weather service, and the Danish Meteorological Institute, that has a special interest in Greenland, that the ice mass of Greenland has been increasing. Are these contradictory? Not necessarily. After all, increasing ice on an ice sheet pushes peripheral ice into the ocean. So both could be true, but if you leave out half, you don't have quite the picture. Okay, so where are we? Misrepresentation, exaggeration, cherry picking, or outright lying pretty much covers all the evidence. So we reach a conclusion. There you have it. Implausible conjecture, backed by false evidence, or less kindly, fake news, and repeated incessantly, has become politically correct knowledge. And it is being used to promote the overturn of industrial civilization. What we will be leaving our grandchildren is not a planet damaged by industrial progress, but a record of unfathomable silliness, as well as a landscape degraded by rusting wind farms and decaying solar panel arrays. False claims about 90%, 97% agreement will not spare us, but the willingness of science to keep mum is likely to much reduce trust and support for science. And perhaps this won't be such a bad thing after all, certainly as concerns official science. there's at least one positive aspect to the present situation. None of the proposed policies will have much impact on greenhouse gases. Thus, we will continue to benefit from the one thing that can clearly be attributed to elevated carbon dioxide, that is, namely, its effective role as a plant fertilizer and a reducer of the drought vulnerability of plants. Meanwhile, today, the IPCC is claiming that we need to prevent another 0.5 degree centigrade of warming, since the 1 degree centigrade that has occurred so far has been accompanied by the greatest increase in human welfare in history. As we used to say in my childhood home of the Bronx, go figure. Thank you.